right, I wanted to discuss some of the common errors that I saw in the formative yesterday to try to guide you as you review a little bit more today. So with question number 1, it's asking us to create a solution of calcium chloride. The first thing that I need to realize is that calcium chloride is CaCl2, okay, so I'm using those ions. Calcium is 2 plus, chlorine's -1, so I need 2 of those. So I'm converting that into a formula here. And I just want to make a solution of this thing. So I'm not doing stoichiometry where I'm relating it to something else in a balanced equation. It's not a reaction. I'm just taking some of that solid and I'm adding some water to it. Okay, and it's asking me like, how would I create that? So I need to know how many grams of that calcium chloride do I need to dissolve in some water to make that final solution that I want. Okay, so when in doubt, go to moles. That's true for the entire unit. And there's 2 ways that you could approach this. You could just use that molarity equation where you've solved for moles and you're just multiplying liters times molarity. And then once you have moles, you're using the relationship of 1 mole is equal to its molar mass to solve. Notice that's essentially still what we're doing in the boxed work here, but instead of just using the molarity equation, we're using molarity as a conversion factor. So we're taking this molarity here and we're saying, well, I would have 2.5 moles if it was a 1 liter solution. Notice in this problem, it's not 1 liter, it's about 1/4 of a liter. So I don't have that many moles. But if I assume 1 liter, I can use this as a conversion factor. So that is what this is here. That is that molarity that's been turned into a conversion factor. So for these problems, you will never ever start with molarity. You will use molarity as a conversion factor, okay? And so then once we have moles, we are able to then get grams using molar mass and solve. The SEP2 part of it, of like how would I create this, is just really asking that you know that we're going to use that volumetric flask like we did in class when we made that salt solution. So that's one of the skills. And really also knowing that we have to add the solid first, because if we don't, it will overflow. So the total volume of the solution is 0.225 liters. That's with the solid and the water. So you don't add 0.225 liters of water, because if you do, the total solution will be more than what you wanted. All right, for problem number 2, most people did really well with this one, so I don't have a lot to say. The big things that I noticed, some of us are still struggling with writing those balanced equations. You do need to look the ions up in order to get neutral compounds. And then we're also, for the products, we're looking to see which thing is insoluble. To do that, I'm looking at the solubility rules to see that barium sulfate is insoluble. When I'm drawing this out, all of my aqueous compounds break up into ions, and I should have as many as there are in this balanced equation at the top. And then finally for the solid at the bottom, the only difference with the solid is that it does stay together. It is still made of ions. Notice we still have charges, but it does not dissociate. All right, now on to the calculations. Now it's asking us to use this balanced equation up here to solve the problem. And it's saying calculate the volume of sodium sulfate needed to react with 7.5 grams of barium chloride. So as I said earlier, we will never start with molarity. We will use it as a conversion factor. So instead, we will start with our grams of barium chloride. You can also think about like, which thing do I know enough about to get moles? And the barium chloride, if I know grams, I can find moles using molar mass. The sodium sulfate, I don't have enough information to find moles. So if I think about that molarity equation, liters is equals to moles divided by molarity. So I don't know liters and I don't know moles. So I can't really start with that 1.5 for a lot of different reasons. All right, so in our calculation, we're gonna start with 7.5 grams of barium chloride. We're gonna use that molar mass of barium chloride to find moles. Notice my formula for barium chloride is BaCl2. Many people miss this because they had the wrong formula and therefore the molar mass was incorrect. Then to cancel my moles of barium chloride in my mole ratio step, I put barium chloride on the bottom, and I want to end up with sodium sulfate because that is what it asked me here, okay? And then this last step, a lot of people messed up because they just went straight to grams. I think you feel comfortable converting to grams because that's what we did in first semester, so some people are just really on autopilot with that. But this asks for volume. And volume is going to be measured in liters, we're going to assume, unless it says milliliters. Okay, so my last step, I need liters in the numerator because that's what I'm trying to convert to in the end. And so in order to find that liters, we're going to use the information about my sodium sulfate that was given as a conversion factor. So when I look, I see 1.5 molar sodium sulfate. If we are to convert that into a conversion factor, if I had 1.5 moles of it, it would be a volume of 1 liter. Now remember, we don't have 1 liter of it. We're trying to figure out how many liters we do have. But if we assume 1 liter, then we can use 1.5 moles and 1 liter as a conversion factor. In this case, I do put my moles of sodium sulfate on the bottom so that it will cancel with that moles of sodium sulfate in the top. And then when I solve, I get 0.024 liters. If you don't like using molarity as a conversion factor, you can alternatively use the molarity equation at the end of the calculation. So you could stop here once you have moles of sodium sulfate and then plug that into the molarity equation. There were a couple videos from Tuesday that show you how to do that. Okay, and then finally, and this kind of relates to this problem too, some people were asking, like, is there like a map for how I solve these problems? And so I think this might help you when you're planning a problem, because I did see many people kind of going the wrong way in the mole road. And I can address that when we talk about this question D here, but like, let's say we solve and we have moles of one substance and we want to end up with liters of another substance. There were some people yesterday who were going backwards to grams, and then they would see, ooh, I don't need grams, I need moles, and so they were going back this way. So you would never do that. You're always trying to head towards the thing that you're trying to find. So I think maybe the road map will help us when we're trying to figure this out. So let's see, this problem, it's giving us amounts of barium chloride, it's giving us amounts of sodium sulfate. Again, we're still using this balanced equation from above. Everything is a 1-to-1 ratio for that. And I'm starting with liters and molarity of barium chloride, liters and molarity of sodium sulfate. So basically, I am here for both problems, and I'm trying to end up with grams. So my first step will be to convert from liters to moles using that molarity as a conversion factor, mole to mole using my mole ratio, and then moles to grams using molar mass. Another really big common mistake that I saw was going to the wrong thing at the end. So this is grams, it says, of the precipitate. And my precipitate, we have to look back up here. My precipitate was the barium sulfate. So the end of those problems should be about barium sulfate. And many people, for some reason, related each reactant to the other one, or maybe to the sodium chloride instead, because you weren't thinking about the fact that the precipitate is a solid. There were a lot of different kinds of mistakes, I guess, that I saw on that. So just to kind of walk us through, we have barium chloride. We're starting with that. We're starting at liters. We want to convert to moles. So I can use that molarity as a conversion factor if I assume that I have 1 liter of that solution. I would have 0.5 moles. So that allows me to cancel out my unit of liters of barium chloride here. Now I'm in moles of barium chloride. Now I need to relate that to the barium sulfate, so I'm using that mole ratio, 1 mole to 1 mole from the balanced equation. And then finally it's asking for the grams of that precipitate, so I do know that 1 mole of barium sulfate is equal to its molar mass. I do the same thing for my sodium sulfate because I need to see which one of these reactants is going to run out first because that's the one that will limit how much product we can make. So again, I'm starting at liters for this one. I want to convert to moles using that molarity as a conversion factor. Then I use my mole ratio from the balanced equation. It is a 1-to-1 relationship. And then finally, I'm converting to grams of barium sulfate again at the end. So your final step for these is to look and see which thing is going to run out first. And the one that runs out first is the one that makes the least amount of product. So once I make 2.33 grams of that solid, I am then going to be out of my barium chloride. So I'm limited in the amount of product I can make by my amount of barium chloride, which is going to run out. All right, let me know if you have any questions today. I'm happy to respond in formative.com. I could send you a video response. I can send you an audio response. I'm really here to help you as much as I can from home today. All right, have a good one. Bye.